Hello everybody, this is Kevin Xu, the author of the Interconnected newsletter on Interconnected.blog, the internet's only bilingual newsletter on the intersections of tech, business, investment, geopolitics, and US-Asia relations. I also run the Interconnected YouTube channel. Today's segment is another narration of a post that we published on Interconnected. This is part 2 of our exploration of low-code, no-code, written by one of our guest contributors, Shawn Xu. Shawn is one of the early engineers at Ascend.io. He got his master's in human-computer interactions at Carnegie Mellon and writes a very informative WeChat public account in Chinese on SaaS called 硅谷成长规律. Alright, without further ado, let's get into this part 2 of Low Code, No Code by Shawn. In part 1 of this 2-part series, I focused on the overall low-code, no-code landscape, major product categories, and a landscape graphic of more than 360 companies in this ecosystem. In this part 2, I will share some thoughts on the driving factors behind this latest low-code, no-code wave, a rubric for evaluating different products, and how the low-code, no-code ecosystem is developing in China. Let's talk about the rise of low-code, no-code first, at least the recent rise. Low-code, no-code is actually a 20-year-old concept. It's enjoying a recent boom for a few reasons. The first reason is imperative to declarative programming. Imperative programming is all about commands, while declarative programming describes the end result. A good example will be telling some friends who are visiting you where your home is. In the imperative way, you'd say, get on Highway 101, exit at Fair Oaks Avenue, turn right at the post office, and second left after the 7-Eleven. It's a list of commands that should get you the result you need, but doesn't actually describe the result. In the declarative way, you'd simply declare the address of your home and offload the navigation to, say, Google Maps. Declarative programming has its apparent advantages, where engineers can focus on what the end result should look like rather than the messy intermediate commands to get there. SQL, or SQL, is one great example that embodies the declarative paradigm, thus it remains one of the most widely used query languages, even though it was created more than 45 years ago. Similar trends are emerging in different layers of the technology stack, from front-end frameworks like React.js and Vue.js to infrastructure management and DevOps like Terraform. The shift from imperative to declarative is yet another story of abstraction, which is at the essence of the low-code, no-code movement. Recall from part 1, our definition of low-code, no-code is abstract away one or more steps in the software development lifecycle. In essence, this furthers the abstraction progress of declarative programming, so the act of programming itself is removed. Another reason is digital expressiveness. As more of our lives become digitized, the need to express ourselves digitally also increases significantly. From a wedding registry to an online shop selling homemade desserts, from a customized team-building exercise to a mobile game that needs a fan site. Anyone can become a digital builder. You don't need a computer science degree, you just need the right tools. We have yet to witness the full power of this trend, as many tools still remain technically challenging and require some amount of heavy lifting. But some of the companies I mentioned in part 1, especially those in the rapid builders category, and I highly encourage you to listen to that audio narration on our YouTube channel, they have begun to smooth out the rough edges to make everyone a developer. Now let's talk about the journey to the cloud. Much like The Journey to the West, which is a classical Chinese fiction depicting the epic pilgrimage of a monk and his disciples to obtain sacred Buddhist texts from India, traditional enterprises are experiencing similar hardships as they transition to the cloud. The biggest challenge comes from the lack of engineering talents. Old organizational structure and culture make attracting top talent and competing with companies like Google and Facebook difficult. Low-code, no-code becomes a critical interface to help bridge that gap for these traditional enterprises, moving data from offline to online, launching new cloud-based experiences, stitching data together from various systems. The latest low-code, no-code products have made all of these engineering-heavy workloads easier and smoother than ever before. Let's talk about the rule of 5, my heuristic for evaluating low-code, no-code products. With so many products nibbling away at different layers of abstraction in the stack, how should you evaluate them, either as an investor, a company executive, or an engineer? I'd like to propose the rule of 5. Here's how it works for a hypothetical product X. Efficiency. Does X cut down the time from planning to launching by at least 5 times? Can one person build an MVP with X based on just tutorials and documentation in 5 hours? Can a new employee be ramped up to become productive using X in 5 days? Another dimension is migration. Can existing data and processes migrate onto X within 5 months? If customization is required before integration, can X deliver that within 5 weeks? Another dimension is cost. Compared to building a similar solution in-house, does using X cut down total cost by over 50 times in the near term? If a company uses X 5 times more, or bought 5 times more seats, will the cost increase linearly by 5 times as well? The last category is service and support. If X goes out of service or goes bankrupt, can features and business logics built on X run normally after 5 days of migrating to something new? Can questions posted on X's community forum get answered within 5 hours? When using X, are more than 5% of the problems encountered not solvable by other customers, thus must engage its support team? From the customer's perspective, this list of highly practical needs is what sets truly useful low-code, no-code products from the crowd. Of course, as mentioned in part 1, low-code, no-code products differ in their abstraction levels, so the quantity 5 that I just suggested should not be used rigidly. Let's talk about some challenges facing low-code, no-code products. As hyped as the market may be, we have yet to see clear winners or many low-code, no-code unicorns emerge, compared to other SaaS sectors. Here are some unique challenges that the category is facing. Selling into large enterprises. Like other SaaS offerings, most low-code, no-code products start with a bottom-up sales strategy for good reasons. Acquiring product feedback for faster iteration and using a community-driven approach to spread awareness. That can work for a while in the beginning, but as the product and company grow, it will inevitably have to scale by acquiring bigger customers with larger purchase orders. This scaling into the enterprises can be especially hard for a low-code, no-code product because chances are these larger enterprises already have homegrown all-code solutions for many business use cases that work well enough. Selling into this environment can only mean one thing: navigating a muddy pool of internal politics. Success here would require a ton of relationship building, a slew of shiny features, and more than an ounce of luck. If the low-code, no-code product happens to replace one or more critical business processes owned by an executive, things might get even more difficult, as that executive's career may be on the line. Buy versus build and job security. No one likes his or her job abstracted or automated away. Few people would hesitate between saving their own jobs versus saving some money for their company by adopting some low-code, no-code products. Interestingly, more often than not, these are also the same technical teams making the evaluation and decision between buying or building their own all-code solution. This is especially true when the company executives are less hands-on, delegating these decisions to the appropriate tech team managers or leads. Should the low-code, no-code product pose a credible threat to the engineering team's job security, the final decision is usually a no, followed by the comment, meh, we can build this stuff in a week. Buy versus build and company growth. For a customer company, the buy versus build discussion is not a one-time decision, but an ongoing process that changes dynamically as that company grows. When a customer company is young and lacking engineering resources, buy is often the right, if not the only choice. However, as this company grows, the balance slowly tilts away from buying towards building, as being a bigger company also means the need to buy more seats, incurring more usage, and signing larger contracts. Allocating a few engineers to build a homegrown solution may start to look like a better use of resources. At this juncture, the low-code, no-code product will have to pitch and likely discount hard to fight its customers' urge to build. Let's wrap up by talking about low-code, no-code in China. The US is not the only place where the low-code, no-code ecosystem is red hot. China has a burgeoning ecosystem there as well. Early this year, Alibaba's enterprise product DingTalk, or DingDing, a hybrid of Slack, Gmail, and Atlassian, announced its new direction of building an ecosystem for low-code applications. This announcement triggered much enthusiasm in China's enterprise product community, some even calling 2021 the year of low-code. That being said, China's low-code, no-code landscape is still significantly smaller than that of the US. Between 2016 and 2020, there's only 59 funding events capitalizing a handful of low-code, no-code companies in China. Most of these companies provide either collaboration tools or GUI-based site builders. It's a bit naive and simplistic to attribute the differences to China's less developed B2B enterprise market, which actually outgrew the above low-code, no-code figures by a few orders of magnitude. I think there are two other more nuanced factors at play. The first factor is monopolistic e-commerce platforms. The two main sectors that are fueling the US low-code, no-code landscape are e-commerce site builders and chatbots, which you can see in more detail in part 1 of the series. These products thrive because there's a vast number of independent retailers who need an online storefront with custom branding and customer service functions. None of that is necessary in China, because its e-commerce industry is dominated by a few mega platforms, mostly Taobao, Jingdong, and Pinduoduo. And all these monopolistic platforms already provide a complete set of end-to-end retail solutions, from payment to branding to customer service, in order to keep sellers on their platform. The second reason is building is cheaper than buying. This reason is perhaps more obvious, but we should still put some numbers around it. According to JobUI, a popular employment data site similar to Glassdoor in China, an average developer in Beijing earns about 164,000 RMB or 25,400 USD per year. A food delivery driver makes around 120,000 RMB or 18,600 USD per year. Junior level developers often get paid much less than the average. Thus, the ample and comparatively cheap engineering supply makes build much more attractive than buy for most use cases. When it comes to developer tooling and automation, a crowded low-code, no-code domain in the US, Chinese companies tend to throw bodies at the problem to build their own solutions, rather than considering buying low-code, no-code products off the shelf that may be better. It's an easier decision than their American counterparts. I hope this two-part series on the world of low-code and no-code gives you a solid grasp of what the main use cases are, why this space is growing fast recently, how to evaluate a product, and a comparative lens to how it's evolving in the United States and China. Whether you're an investor, founder, or an employee working in any type of tech company, this is a space worth paying attention to. How low-code, no-code evolves in the future can affect your investment return, how you start your next company, or simply your own job security. Just like anything in tech, both the downside and upside are immense.